Thank you, Pietro. Round of applause for Pietro, everyone. Thank you, Pietro. Two things. Even my wife gives me crap about me sneaking up, so you're not the only one. And I can't forget the second thing, so let's move on. So this is design collaboration at Place La Cité. Hopefully I pronounced that right. My daughter's in French immersion, so hopefully I learned something from her. Start off with a joke. That's what Tom made me do. Don't be this guy. So you're out on site and somebody says, well, why isn't that working? Well, it worked in 3D, so it's probably not my fault. So don't be that guy. The reason it happened that way in the field is because the ball got dropped somewhere. So one of these days I'm going to get this printed on a shirt just for fun. Okay. Is there a way to see what's on here as well? Okay, so let's make sure. Yeah. So this project, we had a lot of input from our designers and our critical trades. So the designers are BBB Architects, Ottawa Incorporated, AAR Limited, because there's no I'm going to pronounce that name, and Smith & Anderson did the electrical and the mechanical. Our trade partners were Mobitel Structures and Dilfo Mechanical Limited. And you can actually see their work right there. That is actually Momitel's steel model, and that is actually Dilfo Mechanical's mechanical model. And now you're wondering what the project is. So what's up here, the blue highlighted is actually what the project is. The gray area is actually existing. So we're actually adding in this large circular atrium space, which is going to be a mixed use. And as well in the back of the building, it's a prefabricated structure that's actually expanding the athletic space. What you don't see on this is also some interior work. So they're actually going to be adding a bistro on the inside. And this is all existing space. So if you go back to the presentation just before mine, laser scanning, getting an idea of existing conditions and so on and so forth. So there's definitely a lot of existing conditions. And the way La Cité is built, it's actually in a big circular shape. And you actually, down the center corridor of this massive circular shape, you've actually got your main utilities, your main services. And this construction is actually going to be tying into that. Right down that circular corridor, you can see there right next to the largest portion of blue in the bottom left corner. And so it's going to have a 350-seat studio space, and it's actually got retractable walls. Once those walls are retracted, you're actually going to have a 1,300-person event space. So Jerry, if you're listening, maybe next year we can do this there. That'd be pretty sweet. And obviously the bistro and the expanded athletic facilities. And just to give you a sense of perspective, that's actually double height. So you've actually got 2 stories of open space, and then you've actually got a catwalk, similar to a theater. So you've got a catwalk space above. You can just barely make it out. It's in orange, and you can see all the M&E that's happening. So normally you'd think, wow, this is a big open space. It shouldn't be difficult. But at the same time, the bigger the space, the more important it is to the client that it needs to be as big as possible. So the client tends to squeeze ceiling space as much as possible, which tends to give us a lot of headache when it comes to putting in the massive ductwork that you need to push the air into this wide open space. So for pre-construction, of course, we had the architectural model, structural, mechanical, and electrical. And we also did a significant amount of design coordination, as the title indicates. And the designers were attending weekly meetings, and they were taking the clashes, and they were having discussions, and it was a very collaborative experience. And one of the things we did, this was an EllisDon initiative, pretty much internal, where we took the architectural, structural, mechanical, and electrical models, we actually pushed them into Assemble. So Assemble is an online system. It's an online system that basically lets anyone with a web browser log in with the proper credentials and actually view and interrogate the model. So The project team in Ottawa on site was able to, with their internet access, open up their browser, go to the website, and look and get a sense of the space and get a sense of what's going on, potentially do some planning on what they're going to do next with regards to what's happening out on site. The estimating team in Toronto. So the estimating team in Toronto, they can all attack the model at the same time and start tagging different objects, and then they can, Assemble has this great thing where you can extract quantities. So similar to the sheets extraction that you can do straight in Revit, this is I'd honestly say a better system. The Revit, it lets you do some level of filtering, but you can actually, if you really go crazy with this, you can actually use SQL search queries, simple query language, to really filter down the information that you're pulling from the model with regards to quantities, with regards to counts and so on and so forth. And of course, jumping back a slide, I was in Toronto. This entire time, this project's happening in Ottawa, and I'm sitting in Toronto overseeing the coordination meetings, overseeing the design coordination meetings, and making sure everything's available to everyone here in Ottawa. Another big thing, obviously, you know, if anyone here, a lot of people here are familiar with how things went before BIM. Oh, you've hit 50% design development, stop what you're doing, produce some 2D drawings so I can review it and make sure you guys are on the up and up. Never mind what happened all the way up to that 50% DD. We're now going to review it. We're going to make sure your drawings are up to speed, and then we're going to say, no, this isn't good enough. This isn't good enough. So it's a static. Forget the word. It's not the most cohesive and collaborative of processes. Whereas once you have BIM involved, once you have something like Assemble and things like that, everything's digital. You don't have to stop what you're doing and flatten your 3D into 2D and produce drawings that are up to snuff, that are 50% DD level, and hand it off to the next person to review, red line, and hand it back. So in this case, we're getting weekly progress models. Every week, we're just getting these models. They don't have to do extra work in order to provide us this information. All they have to do is just give us access to their FTP. The work they're already doing, we're able to plug into. And along those lines, we get this information, we interrogate it, we query it, we ask our questions, and it updates on a weekly basis. It's a much more collaborative process. Another nice thing about Assemble, the different versions. So you can actually compare different versions. So I get a new version of a model week after week. I can actually go back to any previous version and compare it. And you can see it literally color codes it for me. So 2D drawings, you know, oh, every time you give me an updated drawing, you got to cloud what you changed. Guess what? This does it automatically. And then I can also whittle it down and actually only show me things that have been added. Only show me things that have been deleted. So I can quickly extract that to Excel, plug that into my estimate, and go about my day. Trade coordination. So of course, we still took the architectural and structural models, and then we actually started plugging in the mechanical models and the steel models. And this is where things really started getting interesting. And this is where we start using Navisworks heavily. So Navisworks is when we start to actually really start getting into the interference coordination. And we start to look at, well, okay, this doesn't work this way, how about this way? And we start taking viewpoints, and we start taking screenshots, and we start having online conversations saying, well, is this a design issue? Can we fix this through means and methods? Can the trade deal with it? Or do we need to send this back to the designers for them to figure out? This giant duct doesn't even fit in this corridor. Can we downsize the duct? Can we upsize the velocity of the air? So on and so forth. And of course, that file. Now, Assemble was nice. It's a website. Everything's up to date. Whenever anyone logs in, it's the latest stuff. Navisworks, on the other hand, I need to send out the latest. So you have to go to the FTP and make sure you've got the latest file. You download it, but you've got this one file. And this file has a full history of all our clashes, all our screenshots, all our communications. And you can go through and slice it and dice it and take your own screenshots any which way you want. And it also serves as a nice historical database. So every week I'm creating a new file. I still have the old file. We can still go back and get our information on, well, where did we go wrong if we went wrong? Or why did we do this? Oh, well, in week 3, this is why we did this, and so on and so forth. There you go, trade coordination. So you'll actually notice the light blue fingers of duct versus the dark blue fingers in the top right corner in the left-hand image. You'll notice it's very different. And that's partially because, again, the client wanted high ceilings. And because of the steel, that massive duct could not travel that way. It would be exposed, it would be below the minimum ceiling height requirement. So Dilfo Mechanical went ahead, they've managed to figure out how to reroute it, and they got the designer's buy-in to actually reroute it that way and actually have these extra long fingers to the vent locations near the windows. So this is a perfect example of if this hadn't been figured out now, then we would have been stuck scratching our heads at construction time. We would have had to squeeze the duct in order to get it to elbow around where it does, because the steel would not have been dropped as low as it needed to. So this is a prime example of why coordinating well ahead of time helps the finished product. And of course, that's actually trade coordination. You can barely make it out. But there's the steel, there's the duct, there's even more duct, there's piping, and that steel had to be rearranged multiple times. So we have these large air handling units on top of the roof, and obviously it's got steel to support those air handling units, but at the same time duct is coming off the underside, right above used space, right above student space. So in order to get these massive ducts to squeeze into the ceiling, not only do you have to get them past the steel, but the steel has to line up with them. And you also have all these other surfaces running around them. We did have to drop maybe one ceiling 2 inches just to make it fit, and that's because of the flanges. This is the first thing I tell one of my coordinators when they need to be deployed: watch out for flanges. Okay, so you've got a duct. It's a 900 by 400 duct, but guess what? That's not a duct. A duct is so much bigger because it's got 2.5 inches of flanges all the way around it. And don't forget the insulation. And what about the hangers? So there's all kinds of fun stuff that needs to be taken into account. Another nice thing we did, now this obviously looks odd with all these curved ceilings. That's actually a 360 panorama pulled out of the 3D model. So there was one situation, where we needed to know if the air handling units were going to cause an eyesore outside the building. So the discussion was, well, is the client going to be okay with these air handling units on a 1.5 meter ledge, on a 1.5 meter step, which is going to bump them up another 1.5 meters and then make them visible from down below? So what we ended up doing with the miracle of Google Cardboard, actually, we went ahead and did a 360 render from different locations outside the building, and people could actually put it on their face and look around at the exterior of the building and say, yeah, that's not an eyesore. I can't see the air handling unit from here. We're good to go. And of course, in construction, this is jumping back to Assemble again. Assemble's also got a mobile app. So you can actually take the model onto your iPad, walk out on site. Another great thing about Assemble, not only does it let you interrogate the object data and actually pull quantities, but you can also add parameters. So if I add a parameter that says install date in Revit and then synchronize it up, I'm going to have that parameter available to me for me to walk out on site, take a look at a piece of duct and say, today's the date. So this duct has been installed today. So now you're getting to the point of real-time install tracking, where at the end of a project or halfway through a project, you'll know exactly how much is installed. Feed that into your estimate. You'll know how much material you spent to date that's actually physically installed on site. And at the same time, you can start feeding this into potential big data, where you can see, well, 3 months ago, 3 years ago, this trade over here was like really, really destroying everything, and they were not installing properly. They were destroying their schedule. They were not meeting their goals. Whereas this guy over here, sure, he costs an extra $5 an hour, but guess what? He's on time, and he's less of a headache. So then decisions can now be pulled from this information, and you can start making better decisions. And you don't have to be the guy you don't have to be the superintendent think of it, in this day and age, if you're the superintendent and you've dealt with both these trades, you'll know, okay, this trade's better than this one's less of a headache. But what if you don't have a superintendent who's worked with both of them? Well, now you've got data that can do the same thing. That was very quick. And thank you.